All right, guys, we're going to start lesson 2.2 today, which is on angle relationships. We're going to look at several different ways that we can compare and find angle measures given different drawings and different representations. We're going to look at complementary and supplementary angles. We're going to look at the angle addition postulate, angle bisectors, vertical angles theorem. So we're going to throw a lot out there. Um, but it's pretty straightforward. I think you'll understand it when you see the examples, and these examples are the same ones you're going to be working on tonight for your homework. So let's first of all talk about adjacent angles. We've mentioned these before, but haven't clearly defined them. Adjacent angles are two angles that are in the same plane. They share a common side and a common endpoint or a common vertex, but they have no common interior points. So what that means is, if you look at angle 1 and angle 2 in this drawing right here, um, angle 1 and angle 2 share this common side, this ray. They share the common vertex, but none of the points inside 1 are also inside 2. So basically, adjacent angles share a side. They're right next to each other, but they don't overlap. Same thing happens here. Here's angle 1, here's angle 2. They share this common side. All the points on the interior of 2 are not any of the points that are interior of 1. Let me give you an example, though, of a couple of descriptions that are not adjacent angles. So if you look here, they say angle 3, which is this angle, and ABC, which is this angle. Now, those two are not considered adjacent. Now, here's why. They do share BC as a common ray, right? ABC and angle 3 both share this common side. They share a common vertex also. But the points on the interior of ABC are all of these points. The points on the interior 3 are these points. They share these points in common. That means they're not adjacent. Okay, adjacent are more side by side. These overlap. Over here, angle ABC and angle 3, okay, those two are not adjacent. They don't share a common side. They don't share a common vertex. It's true they don't have any interior points common, but they don't have the side of the vertex. So these are not adjacent. They're pretty easy to spot adjacent angles. We're also going to talk about an angle bisector. Anytime we're bisecting something, is we're cutting it into two congruent parts. So an angle bisector is a ray or a segment that's going to divide an angle into two congruent parts. So if we look at this example, angle QTS, and then look at ray TR, sometimes it'll just say there's a point inside the angle that divides it, or a ray through that point will divide into two congruent parts. In this case, this TR, this ray TR, is a bisector to angle QTS because it divides it into two 60-degree angles. Since the angles are congruent, then this is an angle bisector. This TR bisects the angle. Okay. Complementary angles. I know you've heard of these before, done stuff with it in the past. Complementary angles are two angles whose measures have a sum of 90. Now, they can be adjacent angles. So look at angle 1 and angle 2 are adjacent to each other. And then I put this little box in the corner, which means this is a right angle. So that means angle 1 plus angle 2 have to add up to 90. That makes them complementary angles. But they don't have to be adjacent. They could be just two separate angles, like angle A and angle B here, one's 65, one's 25. If I add those two together, I get 90. So A and B here are complementary as well. They can be adjacent or they can be separate. Supplementary angles, these two angles got to add up to 180. Okay, so the drawing here, see how this is a straight line right here? Okay, we also call these a linear pair, if you remember, but angle 3 and angle 4 here, because they make up a straight line together, their non-common sides are a straight line. That means they're going to be supplementary, which means their angle measures are going to add up to 180. This is also a linear pair. Okay, but they don't have to be that way. You could have angle Q and angle P totally separate from each other. This angle measure plus this angle measure equals 180. So these two are supplementary as well. Okay, so we're going to work with that idea. The first thing they ask us in tonight's homework is, define the complement of an angle. So to find a complement of an angle means what would I add to the given angle so that those two would equal 90 together. So the complement of a 44-degree angle is 46 degrees because 44 plus 46 is 90. I got to know what makes the 90. So its complement would be 46. To find the supplement of an angle, you'd be finding what you need to add to it to make 180. So in this case, 93. 93 plus 87 is 180. So the supplement of an 87-degree angle is 93 degrees. So they're kind of written like this, the first few questions tonight. Okay, then we'll get some that look like this. So it's find the complementary or supplementary angle. So in our drawing here, you can see that angle 1 and angle 2 are going to add up to 90 degrees just based on the drawing. Angle 2 is 51. So I just write a simple little equation. I know 1 plus 2 has got to equal 90. We know 2 is 51. Subtract 51 and 1's got to be 39. So angle 1's got to be 39 degrees. Over here, this is what we call a linear pair, right? They're non-common sides. This is their common side right here. Their non-common sides make a straight line. So we know this has got to equal 180. So I know 1 plus 2 is 180. I know angle 2, they tell us, find angle 2. They tell us angle 1 is 139. So angle 2 is going to be 180 minus 139, which is 41. And guys, write this stuff out. Explain how you know these answers, okay? It's important. So that's how we do those couple of questions. Okay, now they throw some at us with some variables and make us do a little equation solving, but the concept's the same. Based on the drawing, what do we know? Well, we know 1 plus 2 equals 180 because they are a linear pair. They are supplementary. Angle 1 is 3x. Angle 2 is 8x plus 4, so substitute that in. Okay, left side of my equation, I have like terms, so let's put those together. 11x plus 4 equals 180. Subtract 4, divide by 11, x is 16. Now, make sure you don't stop because the question says find the angle measures. You found the value of the variable, but that's not the angle measures. That's a very common multiple choice error. All right, so let's finish up here. Angle 1, they said, was 3 times x. We know x is 16, so angle 1 is going to be 48 degrees. That's the first answer. Angle 2 is 8x plus 4. X is 16, so 8 times 16 plus 4. That's going to be 132 degrees. Now there's my two answers. Okay. This leads us to the answers, but it's not the answers. We had to go ahead and finish. Okay. Another example, but now we're dealing with not supplementary angles, but complementary. Again, this little box in the corner means this is 90 degrees. So we know 1 plus 2 is 90. 1 is 3x, 2 is x plus 14. 4x plus 14 is 90. 4x is 76 when we subtract our 14. And then x is 19. Again, this is not the final answer. This is the value of x, but I got to find the angle measures. So make sure we finish here, right? Measure of angle 1 is 3x, so that's going to be 3 times 19, so x is going to be 57 degrees. Okay, angle 2 is x plus 14, x is 19, so 2 is 33. So there are your two answers. Okay, make sure you complete the process. All right, this kind of brings us to, and we really worked on it just now, but it's called the angle addition postulate. Very similar or same concept as a segment addition postulate that you've already had. The angle addition says this: if B represents a point that's on the interior of this angle AOC, then when I draw the ray OB, I can now see that the two angles that make up this overall, so AOB, that angle, plus BOC have to equal the overall angle AOC. So this angle measure plus this angle measure equals the entire angle. Okay, so the larger angle is equal to the sum of the two smaller angles. Okay, we really just kind of did that when I showed you how to write those equations for complementary and supplementary angles. But now you can see you're not locked into a complementary or supplementary. It's just any angles they want to create. Okay, so let's take a look at an example. So now you can see that the overall angle QPS is nothing special. It's not a 90. It's not a 180. So we're going to not just jump to that conclusion, but they give us enough information. They tell us angle 1 is 73. That's this angle right here. And angle QPS, which is the overall angle, is 141. So we're going to write a simple little equation. We know that angle 1 plus angle 2 equals angle QPS. That's the angle addition postulate. Angle 1 and angle 2 added together equal the overall angle. Now substitute in what you know. Well, I know angle 173. I know angle QPS is 141. Subtract our 73, and we now know the measure of angle 2 is 68. And that's what they asked us to find. Find the measure of angle 2. We got it, 68 degrees. So that's angle addition. Another one. Now this one they ask you to write kind of your own representations of the variables and or the angles, and I'll show you what we're talking about. So they're telling us that WXZ, so WXZ is the entire angle. That equals 115 degrees. And now they're saying the measure of angle 2 is one more than the measure of angle 1. So they're not giving us expressions to represent these. They're making us do it. All right. Now, since I'm basing the measure of angle 2 on angle 1, I'm going to make angle 1 my x. So if angle 1 is x and angle 2 is 1 more than that, then angle 2 is x plus 1. Okay. Now, what do we know about angle 1 and angle 2? Well, if I add them together by angle addition, it equals the entire angle. Substitute in what I know. X plus 1 equals 115. 2x is 115. Right? Combine like terms on the left side. Subtract a 1, divide by a 2. X is 57. Now make sure you answer the question. This is not the answer. That's the value of x. They say find the measure of angle 1. Well, angle 1 was my x, so I guess in the long run, this really was the answer. But angle 1 is 57 degrees. That's what they wanted. Okay? So that's an example of having to write your own expressions and then use them. Okay? This one they throw the concept of a angle bisector at us. So if we read the whole thing here, in this figure below, JKM, so JKM is the overall angle. It's 103 degrees. LKM right here, this is 70 degrees. And KN bisects LKM. Our job is to find JKN. So JKN, we got to find this angle right here. Okay. So the first thing we are given is that, or the first thing that we start to use, I should say, is that KN bisects LKM. And LKM is 70. So if this LKM is 70 and KN bisects it, then we know that each of these are 35s. So that's 35, that's 35, right? Because the overall is 70 and KN cut it in half, so 35, 35. The next thing we know is that if I was to take all three of these angles, JKL plus LKN plus NKM, those all have to add up to the overall angle, which is JKM. All right. Now, remember that we're trying to find JKN in the end. So what I want to do is find each of these individually, and then I'll put the two together I need to get the answer. So that's why I'm doing this. So if I just plug stuff in, JKL is what I'm looking for. I know LKN is 35, NKM is 35, and the overall angle it told us was 103. So that's that 70 that we knew that LKM was. And you could have jumped to that earlier if you wanted to. But subtract your 70. Now I know that JKL is 33. So this angle has to be 33. Okay, so to answer the question, find that should say JKN. All right, that should say J, okay, which is this angle. I kind of highlighted in black. I want to find that angle. Well, I know that JKN is equal to these two added together. That's angle addition. And that's going to be 68. Now I'm showing a whole lot more work than what you guys probably will, but I want you to see where this all comes from. Angle addition, substitutions, just making up the overall process. Okay. All right. A couple more ideas here. Intersecting lines and vertical angles. We've kind of talked about this already as well, but remember that intersecting lines are going to create four angles. And angles that are across from each other are congruent. So I know 1 and 3 are the same measure, and 4 and 2 are the same measure. So what this is saying is, here's your drawing, and angle 4 is 33 degrees. If that's 33 degrees, what are the other angles? Well, if that's 33 degrees, then angle 2 is 33 because they're vertical, right? And now I know that any two of these make are supplementary together. They're a linear pair. So I say angle 4 plus angle 3, these two angles have to add up to 180. So angle 3's got to be 147. And if 3 is 147, then 1's 147 because they're vertical. So now I know angle 1's 147, angle 2, 33, angle 3, 147. Okay, so that's pretty straightforward there. Now this one says we got to find the values of x and z. So they're really not saying find the angle measures. They're saying what does the value of x and z have to equal? Okay, so looking at the drawing, you can see that the two expressions that they have x's in are vertical to each other. Since these two are vertical, they got to equal each other. All right, so now I got to solve this equation. So I subtracted 5x, that gave me 8x. I subtracted 48 from both sides, that gave me 32. I know x is 4. So I got the value of x, that's 4. Now, how are these two related? Well, these two together are supplementary, right? They're a linear pair. So I know that 5x plus 80 plus z has got to be 180. Okay. Well, we got two variables, but we actually know the value of one of them. So I know x is 4. So I'm going to go ahead and put the 4 in here. So now I know 20 plus 80 plus z is 180. 20 plus 80 is 100. Plus z is 180. Subtract it. And now I know z is 80. So now I know the value of x and z. X is 4. Z is 80. And again, we're using the same ideas we've been using the whole time. All right. So those are the ideas that we're going to work on tonight. Uh, Guys, make sure you're writing out work and showing some detail. Whatever you're thinking to get the problem done, write it down so that I can see it. All right. That's all going to be credited as homework work. And it's important that you get it done and turn it in. All right. Okay. I'll let you get at her.